Today we get into square roots. It says, what does a square root of x mean, and how does it relate to x squared? That's what we're kind of focusing on today. How a square root and a square, okay, are kind of similar. So it says, for your notes part, you're going to do a lot of filling in here on this first page. We find the area of a square by multiplying length of a side by itself, right? If it's a square and all the sides are 4, 4 times 4, length of a side by itself. Make sense? Should be writing this down. So this can be expressed with that formula, the area equals a side times a side, right? We just never thought to write it that way. Now underneath it says, but since we don't use the dot for multiplication anymore, we express this relationship with the formula area equals side squared. And again, side squared means side times side. Okay. So that's probably something you never always thought about for area of a square, right? Side times side squared. A number times itself. So let's say if all the sides were 4, you'd say 4 squared. 4 times 4. 4 times itself. All right. So if you know the area of a square, you can work backward to find the length of a side. So this is where we're going to go. We're going to eventually go back to remember the chart there in 2.1? We're going to show you guys how to find those squares, the side lengths from this one here, right? Remember we left that far right column open? Right? Yes? No? All right. So, for example, suppose a square has an area of 9 square units. So the inside of a square, the area is 9. All right. To find the length of a side, you need to figure out what positive number multiplied by itself equals 9. So what positive number multiply itself equals 9? Quan, you should be writing this down. Okay. So because 3 times 3, or 3 times itself, equals 9, the length of a square, the side length of a square is 3 units. So the number 3 is called a square root of 9. Because 3 times itself gives you 9, so if you take the square root where 9 came from, that's 3 times itself. That's why we call it the square root. Okay? Now, for any square, if the area equals side squared, then S is a square root of A. Right? Because it would take S times S to give you A, right? So S, that's S squared. So S is a square root of A. So for every every positive number has 2 square roots. 2 positive numbers, or remember, 2 negative numbers, right? Because a negative times a negative is what? A positive. Okay? Just like we wrote down right here. Negative 3 times negative 3 gives you the same answer as 3 times 3. All right, so this means that 3 is a square root of 9, and negative 3 is a square root of 9. Okay? So you can almost write this as, so the length of a side, you can write it as positive with a minus sign underneath it. So the square root of 9 can be positive or negative 3. That's where that plus minus comes into play at. Okay? So again, the square root of 9 is positive or negative 3, not 3 squared. Okay? Not 3 squared. It's the root number. All right, now, this is kind of important here, the bottom part. Special note, 0 is not a positive or negative number. 0 has just one square root, 0. So the square root of 0 is 0. All right? 0 is kind of that no man's land number. All right. There's one thing I need you to change down in here. You see where it's in red? So cross out the word number and write square root of a number. So for any positive number, n, the square root of n indicates the positive square root of n. So obviously, if the square root was 3, that means it's the square root of 9 is its square root, right? All right, so for any negative square root of a number, n, so you see how the negative's out in front of the square root of n here? All right, indicates the negative root. So for example, this, if I did the square root of 9 and this, I got two different answers here, right? This is positive or negative 3. This is just negative 3 because you're only taking the opposite, the negative of it. All right. All right, so that's what that means. All right, you cannot take the square root of a negative number. When we say negative number, that means something inside the radical sign. So for example, oh, it didn't show up, but so if the negative 10 was inside the square root, okay, that's something that we call a complex number or imaginary number, and you're going to learn about that a little ways down the road, not this year. So if you got a negative inside the square root, that's a little bit different than what we wrote out here with the negative outside the square root, right? You're taking the square root of a number here, a positive number, and then taking the negative of it. Where here, you're taking the square root of a negative number. No number times itself can give you a negative number, right? 3 times 3, negative 3 times 3. You can't take 3 times negative 3 because that's not the same number, right? So no two numbers will give you a negative number when you multiply them together, especially when they're supposed to be the mirror image of the same number. All right, so this right here is extremely important. You do not have the tools yet to figure this out. Is there an answer to this? Yes, but you're not ready for it. All right, so this symbol, the square root symbol, does anyone actually know what it's actually called? There's actually a special word for it. It starts with an R. Anyone have an idea? Surfers say this word a lot. Do you know? Radical. It's a radical sign. All right, so there's kind of our introduction to all this. All right, everyone got that front page all set up? All right, moving on. So some questions that we're going to come back to later. What is the side length of a square with an area of 2 square units? All right, so we'll come back to these questions later. So here we go. Let's move on here to part A. So go back to the column marked side lengths in your 2.1 worksheets. Find the side lengths of squares with areas 1, 4, 9, 16, and 25. So let's do this. All right, we're going to bring up that 2.1 worksheet. Hopefully you have it in your notes, not in your locker. Let's let it come up here for a second. All right, so if you remember, in this column, right, so this had the area of 1, right? So we're talking about this one, this one, this one, and that one. So it says take your calculator and find the values for the square root of 1, the square root of 4, the square root of 9, the square root of 16, and the square root of 25. Well, what's the square root of 1? Whoop. I'll lock this up here so this doesn't move when I move it. All right. So the square root of 1. Right. The square root of 1 is 1. Because 1 times 1 gives you 1, right? So the square root of 1 is 1. So that means that this side length is 1 unit, right? What's the square root of 4? 2. Square root of 9? 3. Square root of 16? And the square root of 25? That's 5. All right, so jumping back to our other sheet real quick. So we found these numbers to be 1, 2, 3, 4, and 5. So what do you notice about those numbers? Yeah, the consecutive these numbers here increase by 1 every time, right? They're also, number 2, when you multiply these numbers here by themselves, by itself, you get the number inside the square root, right? Right? When I multiply each of those numbers by itself, we get the number inside the square root, correct? Thank you. Yes, yes. I know it's Monday. Wake up. What also is 1, 2, 3, 4, and 5? A certain classification of numbers. What are 1, 2, 3, 4, and 5? Yeah. Whole numbers. They're all whole numbers. All right, so we're going to come back to our other sheet here in just a minute. So, what is the area of a square with a side length of 12 units? So remember, they gave us that formula earlier of area equals side squared, right? Right? So if a side length is 12 units, right? What are we going to do that 12? Jamie? Not by 2. Side squared. You're going to multiply it times itself, right? You're going to get 12 squared equals the area, right? And 12 squared, that's like saying this, remember? 12 times 12. You're multiplying 12 times itself 2 times. That's what a square means, not multiplying by 2. So what's 12 times 12? 144. So the area would be 144. What would the area of a square be if the side length was 2.5 units? How would you find this out, Stephen? Right. 2.5 squared, right? That's like saying 2.5 times 2.5, which is 6.25 square units, right? And this was square units also. All right, getting in the habit of trying to think of squares and square roots, how they work together. So, find the missing numbers. So, if there's no number underneath the square root.
Excuse me, can Angelina come to the office for a minute?
Sure. All right, so the square root of some number is 12. What do you think? What number should go underneath here? What number's missing under here? The square root of some number is 12. Square root of some number is 12. 144, right? Because again, this number is the root of this, right? Which means that number times itself would give you that number. So 144 is correct. Very good. So what about for B? The square root of some number gives you 2.5. We should have just did this work, right, Blake? Right, 6.25. And again, we know that because, well, number one, we just did that work up here, didn't we? 2.5 times itself. So to find these answers, you take this number that's right here and you square it to find the number that fits inside the square root, right? Bless you. All right, so now let's think of it as a little bit backwards. Find x. So x squared, some number squared, gives you 121. You gotta go back to your multiplication tables now. So 121 is the root of what? What times what? Stephen? 11. Right? 11 times 11. And again, there, if you don't know the mathematical, let's say you're not good with your times tables, there's an easy way to solve this. Again, if I want to find x, all right, if I take the square root of a number squared, so if I square root both sides, the square root of any number squared is x. Okay? Because x times x gives me x squared, right? So if I take the root of x squared, that's just x. And then I just said, what's the square root of 121? He said 11. So you could actually work backwards like that. So if you have anything squared, let's say we took the square root of 2 squared. Well, that's just 2, right? That's what that means. All right, what about this one? This might be a little more tricky. B. Some number squared gives you 2.25. Some number squared gives you 2.25. Katie? 1.5. How'd you figure that out? The square root of it, right? Yeah, when you square root both sides, the square root of 2.25 is 1.5. Now, this is where you got to be careful with C and D. C asks you the square root of some number is 121. So this number here is the root. So should x be a bigger number or a smaller number than 121? Look what we did up here. Bigger, right? So over here, we took the square root of both sides. Well, here, what you're going to have to do is that number to find the number underneath the square root. What do we do over here? What do we do to these two roots to find out what number is underneath the square root? We squared them, right? So you got to square 121. 121 times itself. That's a big number, isn't it? What is it again? 14,000. So x is going to be 14,641. So the square root of this number is 121. It's a big number, isn't it? Now you notice D isn't the same as C, isn't it? No, we have a number underneath the square root now. We want to find the root of that. So what's the square root of 2.25? The square root of 2.25 is what? Jamie? Yeah, we actually did that in B, right? When we found x squared, we took the root. We ended up taking the square root of 2.25 to find the answer. So x here is 1.5. All right. So it says explain what each positive value of x in part 3 means. So in A we came up with, we got this, right? So we took the square root of 121. So A would represent a side length in terms of area and length, right? Because we square a smaller number to get a bigger number, right? So the answer that we found in A is a side length. When we go smaller number to big, or big number to smaller number, or vice, then we're talking about area. Like for example, C. Do you see C here? we had to find out what was the root of this number, right? So we had to square this. So the answer we get in C is the what? We're talking about length and area. If this is a number we had to square to find this, that means that this number must be the, think of area and length. Is this area or length? Area, because it's a big number, right? And actually, B and I think it's D are all side lengths because we're finding the smaller number. We're finding a side length. So A, B, and D would basically be the equivalent of side lengths if these were area questions, and C would be the only one that was an area. All right, so let's go back to our 2.1 then. Knowing what we know. All right, let's do the squares that were irregular, right? Because you notice all the perfect squares, they got nice whole numbers, right? We found their side lengths, right? Taking the square root, it was nice and easy, right? Well, now we have the area is 2, right? So if we use our little formula, and I plug in 2 for the area, how do I find my side length? If 2 is the area, and that's the area of two sides that are squared, how do I find one side? What do we do? What do we do just on the other sheet, Jamie? Square root both sides, right? And when I square root both sides, well, the square root of s squared is s, because s times s gives you s squared, right? And then we can just write, without having to write it, because we know this is not a whole number, right? Just write the square root of 2. We know the answer is in between 1 and 2, right? It's a decimal. It's not a perfect square. It's not a whole number. This is what we call an irrational number. So the same thing with 5, right? We want to find a side length. 5 is the area. Okay? How do I find the side length? Square root both sides. So when I square root both sides, s equals the square root of 5, which is actually a number between 2 and 3. How do we know that? Because this side length was 2, this was 3, and this fell between it, right? 8. Square root both sides. Remember, these aren't nice whole numbers. These are decimals that go on forever. Non-repeating, non-terminating decimals. Those are called irrational numbers. So how would you find 10? If we had an area of 10, what would be its side length? Just by seeing the pattern that we've done so far up here of an irregular triangle. The area of 10 would have a side length of what? Blake? Did your hand go up? Huh? No? Never mind. Remember, you don't have to find the square root. Just what would it be? Plug it into your formula. Right? If I want to find a side, what do I got to do to both sides? Square root it. So if the area is 10, that means the side length is square root of 10. Okay? And notice all these square root answers are decimals. All these ones that had these nice perfect squares, the non-tilted squares, right? The beautiful horizontal, vertical lines, have whole numbers for the sides. Okay? The difference between an irregular square and a perfect square, right? Perfect squares got nice numbers, nice sides. Irregular shapes, those squares that are tilted, not so much. Find the square root of 10 on your calculator. What is it? It should be like 3.16. So it goes on forever, right? It doesn't work out to be a nice number. All right. So that's how we can find our side lengths, just by using that formula. All right, let's jump back to our other sheet here and go on to our last page. So it says using the square root key on your calculator, it says estimate the square root of 2 to the nearest 10. So when you type it in your calculator, square root of 2, what do you get? What are your digits before it runs out of room? Andrew. One's repeating? Oh, is it 4, 1, 4, 1, 4?
It's 1.41421356.
Okay, and it keeps going, right? So how am I going to round that to the nearest tenth? I want you to round it to the nearest tenth. So rounding to the nearest tenth, what position is the tenths? Who can tell me what position is the tenths, Anna? Right, this one right here, right? So if we're at 1.4, we look at the next number, right? What's the next number after 4? 1. Right? What's our rule for rounding up? If the number is what? 5 or greater, right? Is that 5 or greater? So what would our answer be? Rounding it. 1.4. All right, so number 2 says, suppose you are designing a square sandbox that has an area of 2 square meters. What is a reasonable and accurate measure for the side length? So think about this for a minute. You're actually, think of a tape measure, right? You got a tape measure, all right? And I'm measuring a sandbox. I'm cutting these pieces of wood. First of all, it's going to be a pretty small sandbox. However, is this going to be an easy cut at 1.4? This is probably something where you would take this number from number 1 and probably round up, right? Because we all know on a measuring tape we're 1/2 inches, right? That's probably much easier to cut than 0.4, right? When you look for that. So you could probably say 1.5 would be in roundup would be easier if you were actually designing a sandbox just for cutting purposes. All right, so between which two consecutive integers, or I should say whole numbers, so when they say back to back, that's like 4 and 5, 6 and 7, 8 and 9. Would the square root of 5 lie between? Don't even try to use your calculator here. Think of where the square root of 5, what the answer would be. What do you think, what two whole numbers would it lie between? William? Why would you say 2 and 3? Okay, so where'd you find it between? Right, you knew the square root of 4 was 2, right? And the square root of 9 is 3. And the square root of 5 falls right in between there, right? So again, when they ask for whole numbers, those are two consecutive whole numbers, you get 2 and 3. So which whole number is the square root of 5 closer to? Is it closer to 2 or 3? Right? Think of this if I write these in order. Square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. So here are two whole numbers that I circled, right? Here's the number that we are looking at. Right? I didn't even write the decimal, I just wrote it as square roots. Is the square root of 5 closer to the square root of 4, which is 2, or is it closer to the square root of 9, which is 3? Look at that visual. What do you think? Come on, somebody else answer. Which number is it closer to? 2 or 3? Same people keep raising their hands. Mind you, is it closer to 2 or 3? Remember, 2 is the square root of 4, right? 3 is the square root of 9. So where is this guy closer to? Right, square root of 4, which is 2, right? So it's closer to 2, right? And again, if you want an explanation, there it is, right? You can visually see, this is kind of the middle area here, right? And it's way to the left of the middle, isn't it? So it's closer to 2, for sure. So here, without using a calculator, can you estimate the value of the square root of 5 to 1 decimal place? So if this is 3, and that's 2, if this was the middle, it'd be what? 2 point what? 5. So it's over here. So someone give me a wild guess. If you were to estimate that to the nearest tenth, what would you come up with, Katie? 2.2? All right. So don't forget, too, when we say 2.2, right, we multiply it times itself, right? So here, let's just do it. Remember, we're not supposed to be using calculator. No cheating. So 2.2 times 2.2. All right, so that's 4 and 4. Put the 0. 4 and 4. Remember multiplying decimals from a long time ago? You guys remember doing that? A little old school here, right? So if I got multiplying two decimals that have a tenth, where does my decimal go? Right? I've got a decimal here and a decimal here. Where does my point go in the answer? Does it go here? Does it go here? This is a long time ago. We're talking fourth, fifth grade. Jamie, which 4 and the 8? This one? Yes, right here. Because that's one decimal place and that's one decimal place. So the 2. So that's 4.84, right? Well, let's test it. If we go up a tenth, what's up a tenth from 2.2? 2.3. So if I do that twice, let's see what happens. Well, that's 9, right? 3 times 3, 6. Nope. So 2.2 would be pretty accurate, right? Because 2.3 is bigger than the square root of 5, right? Bigger than 5, right? The original root. So very good. So we'll go with 2.2. That's how you can kind of use some math to kind of back up that statement. You want to be as close to 5 as possible, right, for your answer without going over. All right? All right, so you have some homework here. Don't panic when you see this. It's the most you've had all year. However, these are all like square root problems, which takes like 1 second to do. Okay? So you'll rifle through 4 to 36 pretty fast. All right? And then on page 35, 73, and 76. So here, I'm going to pause this for a minute.